So in the next few videos, I'm going to be doing solving equations, and I am going to break them into the different types of equations just so that it looks nice and similar, and I will have separate videos for modeling as well as solving using the algebra so that it's very easy to kind of go back and forth for the things you need. So with our models, what we're going to do is I'm going to use these tiles that I've got set up over here on the right hand side. Okay, so with these tiles, so for that first one, I've got this kind of green rectangle here, and what we're going to use that green rectangle to represent is we're going to use that to represent our x's, okay, or our variables. So I can change this from one letter to another if I need. Most of the time it will be an x. And I'm using these green rectangles because we're going to see the exact same models as you move into grade 9 and grade 10. So I'm going to work with what we call our algebra tiles. So if you're in the classroom physically, you will actually be able to have these tiles in your hand on your desk and be able to play with them. The other one I have here is I've got this little square, and I've colored that one in red, and I'm going to refer to that one as being positive 1. Okay. Now, just like we had with our integer chips before, if we flip those tiles over so that they're not colored in, they're still the exact same size, so they represent the same thing, but just negative. So the white rectangle would represent a negative x, and the white square would represent a negative 1. Okay. All right, so what we're going to do is I first off need to model what I've got going on here in my equation. So I've got x plus 5 is equal to 3. So in my model, I'm going to use only my shapes and no other symbols. So I'm going to start off by drawing an x tile, and it's a positive x, so I'm going to color it in green. Okay. And then I have plus 5. So the way I would represent plus 5 is this would be the same as positive 5. So I'm going to add 5 ones tiles, and these ones tiles are positive, so I'm going to color them in red. My x and 5 positive ones, and I don't need any symbols because it says x, and because these are positive, we would think of it as x plus 5 because it's positive 5. Now that's what's on the left-hand side of the equal sign, right? And on the right-hand side of the equal sign, I'm just going to draw a line going down my page, and the line is going to separate one side of my equation from the other. And on the right-hand side, I need to have positive 3, so 3 ones. Okay, 1, 2, 3. And those guys are positive, so I'm going to color them in. Okay. Now our goal when we're working with algebra, and even when we're working with our models, is to get our variable all by itself. So right now this variable has other stuff on the same side as it. We need to get rid of this stuff here. And so the way we would get rid of 5 positives is we need to cancel them out somehow. And we're going to cancel them out using zero pairs, right? That whole idea of a zero pair. So if I have 5 positives, I'm going to counteract that or get rid of the 5 positives simply by adding in 5 negatives. So if I add in those 5 negative 1 tiles, now I have 5 positives, and I also have 5 negatives. These guys here will create a zero pair. Okay, now you don't need to write this part down on your model. You would just need to show me that you're putting in those 5 negatives. So you don't have to write zero pair unless it helps you. So that gives me a nice zero pair. But what I've done is I've totally changed my equation, right? This was how it started, was with this stuff here. And we need to think of our equation as staying balanced. So if you were playing with those mobiles like I had you do in class, you would know that whatever I change on this side, I've now added more stuff here. So this whole side is now heavier than my other side. I need to make sure that whatever I do on one side of my line, I do the same thing on both sides of the line because both sides want to be treated equally. So I also need to add those 5 negatives onto the left or to the right hand side. And when I do that, 3 of my positives and 3 of my negatives combine together to also make a zero pair. All right, now we've got lots of stuff drawn there. So let's simplify and see what we've got left over. So left over, on the left hand side, all of this stuff goes away. So what I'm left with is my x tile. Okay, I'm left with my X tile colored in green. On the right-hand side, all of this stuff goes away, and I'm left with those two blank tiles or white tiles. So in the end, I'm left with X on the right and -2. Or sorry, X on the left and -2 on the right. Now remember, the line that we put down the middle of the page meant equals. So now I have a statement that says X equals -2. And so that's what the missing value for X would have been. This was some number plus 5 had to give me 3. The only number that X can be is -2. -2 plus 5 is the same thing as 3. Okay? We'll do another one really quickly. I don't need to do as much detail here. So I've got X -3, so I'm going to draw my X, and it's positive, so I'm going to color it in green. And then we've got -3, so that's 3 negatives, 1, 2, 3. We'll color them in. And on the other side, I've got 4 positives, so I'm going to draw the 4 of them, and I'm going to color them in red. Okay, positive ones get colored in red. So I've got some number, -3 is 4. Now you can probably solve this one in your head, but we still need to work on how we're solving this using our model. So if I have 3 negatives, the way I get rid of 3 negatives is I counteract them with 3 positives. So I draw in 3 positives. But remember, this equals sign here means now once I've drawn my original equation, anything I change, I have to change on both sides. So because I added 3 negatives on the left, I have to also add 3 negatives on the right. On the left-hand side, my 3 negatives and my 3 positives combine to make a 0 pair. On the left-hand side, all I have in the end is simply just my X. On the right-hand side, I don't have any 0 pairs this time. I've got all positives and then more positives. So together I just have lots of positives. I have the 4 positives I started with, and then we added 3 more on top of that. So in total on the right-hand side now we have 7 positives. So now my statement says X is equal to 7. So I can finish off my statement by writing X is equal to 7. Okay? One very last one. Okay? Oops. All right. So I've got X -4. So that's X -4. So that means I'm going to have 4 negatives. 1, 2, 3, 4. Okay? So X -4 is equal to, and on the other side, I've got to put 9 negatives. So there's 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so there's my 9 negatives on the right-hand side, and sorry, they get messier as I go. Now, I've got my nice equation here, and I want to get X all by itself. I have 4 negatives. The way I'm going to counteract 4 negatives is by adding in 4 positives. But remember, when I change one side, I have to do the exact same change on the other side. So I need to add in 4 positives on the right as well as the left. Okay? When I do that on the left-hand side, these guys make a giant 0 pair. On the right-hand side, 4 of my positives are going to cancel out 4 of my negatives. So those guys also make a 0 pair. And now we're going to look at what's left over. I've got my X, and then on the right-hand side, there are still 5 of my 1s left over. Okay, these ones, because they're colored in white, represent a -1. So I now have X is equal to -5. Okay? And that's how we solve these types of equations using models.